Hello, everybody. Now we're going to be looking at number 4, which is called decider mapping. So it says to complete the function decider map. Decider map takes in a list, LST, and a function decider. Decider is a higher order function that returns a function based on two inputs, a value and an index of that value in LST. So for every value in LST, we're then going to have to determine what function needs to be applied to that value by using decider. And finally, we will return a new list where all values in LST have the function chosen by decider applied to them. So let's go ahead and take a look at the skeleton. We're first given the function decider, which takes in an index and value and will return a function. Then, looking at the first doc test, we have decider map on an empty list and decider, and what we get back is an empty list. This makes sense because there's no values in LST for us to iterate over, so when we return a new list, we'll just get back an empty list. Now, looking at the second doc test, we instead have a list of -1 and -1. So our first index for a -1 would be 0, and the second index would be 1. So it says that we're going to determine what function needs to be applied to that value by using decider. So let's first plug in this first index value pair, which will be 0 and -1. So if index plus value is greater than or equal to 0, we will return this function. So we have 0 plus -1, which is -1. So this if statement is not satisfied, and we will instead look at the else. Now the else says return lambda x of -x. So in this case, what we'll get back is 1, because when we apply -1 into x, we'll get back 1 as a result. So this makes sense. Now, looking at our second index value pair, we have 1 and -1. So when we plug this into our decider function, if 1 plus -1 is equal to 0, which it is, then we will return lambda x of x times 2. So when we plug in the value -1 into this lambda function, we'll have -1 times 2, and we get back -2 as a result. So everything seems fine so far. Now, looking at the second doc test, we run decider map on this longer list and decider once again. So once again, we'll write out the indexes for each value. So looking at our first index value relationship, we have 0 and 1. Well, 0 plus 1 is greater than or equal to 0, so we'll plug in 1 into the lambda function and we'll come back out with 2, as shown there. Cool. So now we have 1 and -5. 1 plus -5 is not greater than or equal to 0, so we'll instead plug -5 into the second lambda function, which will give us back 5. Now onto our third key value relationship, we have 2 and -2. Because 2 plus -2 is greater than or equal to 0, in fact it is 0, we will plug -2 into our first lambda function, and we will come back out with -4. And finally, we have 3 and 4. 3 plus 4 is 7, which is greater than or equal to 0, so we will plug 4 into our lambda function and come back out with 8. Alright, so that's basically the gist of the doc test, and if you understand the doc test, you'll basically be able to do the entire problem. So now looking at the provided code, we have output is equal to this new list here. So it says that in the problem, we will want to return a new list at the end, which we're currently doing with output. But right now, output is an empty list, so I'm assuming that we're going to have to add something to output. For now, let's look at the second line of code, which is for I in blank. Well, once again, take a look at the instructions to see what we can do with this for loop. We know that decider is going to need to take in the index of every value in list. So thinking about that, what we can actually do in this for loop is we can do for I in range length of list. What this will do is it will allow us to get every single index in LST, which we can then later on use to get every single value in LST. Cool, looks good so far. So looking at the second line, we have decided function is equal to blank. Based off the name, it sounds like I'm going to need to set decided function to some sort of function. Well, if we look once again back at the instructions, it says that for every value in LST, we're going to determine what function needs to be applied to that value by using decider. So remember, decider will return a function that we need to use over here and here, but it takes in an index and value. Well, how do we get that index and value? Well, we're currently indexing through every index inside LST. So we can actually get our function by running decider of I, which is our current index. And to get the current value of LST, all we have to do is use index notation and get that current value. So now this will give us a function that we need to use. And finally, before I said that, we're going to want to add something to output, because right now output is an empty list and we're returning output at the end. So most likely what we want to do is we want to append a new value to output. Well, what is this new value? Well, if we once again look back up in the instructions, it says that we're going to return a new list where all values in list LST have the function chosen by decider applied to them. So that's essentially all we need to do. We just need to apply decided function on our current value, which is, once again, list of I. And that's basically the entire problem. So good luck on the rest of the exam.